Hey everyone, welcome into Unit 12, Day 6 notes. Today we are going to be focusing on systems of equations by elimination. So we've worked with substitution the last several days, and now we're going to be working with a method called elimination. So students will be able to solve systems of linear equations by method of elimination, multiplying one equation, including special cases, with an 80% accuracy or higher. Let's get started. When solving systems of linear equations by, you guessed it, elimination, we want to eliminate one of the variables in the system. So you want to get rid of either the x or the y. One of the variables means x or the y. One way we can do this in math is by adding opposite terms. So opposite terms meaning if we're adding 1 and -1, 7 and -7. If we add those, that cancels out, we get 0. So let's take a look at an example, and we'll do our steps along with the example. So we have the system 8x plus 2y equals 38, and -4x minus 2y equals -26. Our first step, identify opposite terms. So in this example, our opposite terms, we have a positive 2y and a -2y. So those are opposites. We've identified them. Step 1. Step 2, add the equations. So the reason why they're nicely lined up with the x's on top of each other and the y's on top of each other is because now we're going to add them. And you can only add like terms, right? So we have to add the x's with the x's and the y's with the y's. So this is nicely organized for us. So we're going to go ahead and add 8x plus this -4x gives us 4x. The positive 2y plus the -2y cancels out. And then we have 38 plus -26, or 38 minus 26 is 12. Okay. Step 3. Solve for the remaining variable. All right, let's solve for x. That's the remaining variable. It's what's left over. We divide by 4 on both sides. X equals 3. Step 4. Just like we did with substitution, now that we have one of the variables, we've unlocked one of the keys to the code, we're going to substitute back into one of the original equations. It doesn't matter which one, just choose one of the original equations and substitute whatever variable we solve for, substitute that value back in. So I'm going to substitute into the bottom equation. We have -4x minus 2y equals -26. So let's substitute it back in. -4. We're substituting x with 3. We have not solved for y yet. And now that we've substituted, now we're going to solve for the other variable. So we're solving for y. This is -12. Add 12 to both sides. And then we divide by -2. Y equals +7. Now, final step. Write the answer as an ordered pair. So our x value is 3. Our y value is 7. Again, remember, this is one method of telling us where these two lines, right? If we were to solve for y, we could graph those, where those two would intersect on the graph. So that is what we are solving for, and they will intersect at the coordinate pair 3, 7. All right, let's try an example here. Number 1. So right away we look, can we identify opposites? Well, the x's are both positive, so those are not opposites. But we do see we have positive y and negative y. Those are opposites, so we're going to add the equations because we do have at least one set of opposites. Those cancel. X plus x is 2x. 4 and 8 is 12. Divided by 2. We get x equals 6. Now we choose one of the equations and plug x equals 6 into that equation. So let's go ahead and let's just do the top one. X plus y equals 4. So we're going to substitute in the 6 minus 6 we get y equals -2. But this is not the answer. The answer is written as a coordinate pair, 6, -2. Awesome. Take a few seconds or a minute or two, try out example 2. See you back in a few. All right, welcome back. Let's go ahead and check out the solution. So we do have opposites, -10x and +10x right here. So let's go ahead and add the equations because we have already identified opposite variable terms. Those cancel out. Now we have -13 plus -2y, or -13 minus 2 is -15, and then 19 26 is 45. We divide, we get a -3, and then again, it does not matter which equation you plug it into. I plugged it into the bottom equation, but you'll get the same result if you plug into the top equation, and we get x equals 2. If you really want to double check your work, you can plug it into both, and you should get the same answer. So we should get x equals 2 no matter which equation we plug it into. All right, fantastic. Let's flip to the next page and let's check out what we have next. Okay, sometimes when solving systems of linear equations by, you guessed it again, elimination, we will not be given opposite variable terms. So that's what we've been given so far. It's already been set up for us to add the two equations, but sometimes that doesn't happen. In this case, we want to manipulate the system, which means we want to follow math law. Let's put this in here. This is true. We have to follow math law. We can't just do whatever we want. We still have to follow math law, but we can do that in a way where we manipulate the system to create opposite coefficients of those variable terms with at least one of the variable terms. In order to do this, here are the two steps. Identify a variable that you want to eliminate. So pick one of the variables. X, I want to eliminate X, or I want to eliminate Y. It technically does not matter which one you choose, but you'll see in the upcoming situations that it's going to be a lot easier to do it with one of the variables rather than do it with the other. So you're going to have to make that choice, but we have to take a closer look at the equations. And then step 2, multiply one or both of the terms to create opposites. So create a set of opposite variable terms by multiplying one of the equations in the system, then solve. So example number 1, we'll do 2 together. You'll do the third one by yourself. So if I look at number 1, we need to just be a little observant here. So x, the coefficient of x is 1, and the coefficient of our y is 5. Now if we look at the x values, we can turn this 1 into, remember we want the opposite of +4. We can turn it into a -4 by multiplying by -4. But if you look at the y values, it's not very, it's not going to be as nice for us to try and turn 3 into a 5 when we into a -5 by multiplying. So we're going to want to choose the easier route, and these are the variables that we want to create opposites with. Now, what do we have to multiply +1 by to make it the opposite of 4, which is a -4? And I know I'm kind of speaking to myself here because this is a video, but the answer is -4. So if we distribute, well, now we have to distribute into the entire equation. -4 times 1x is -4x. -4 times 5 is -20y. And -4 times -21 is +84. So we just manipulated the top equation to create an opposite set of variable terms with our x variable. Again, this is following math law because we multiplied everything in that equation by the same value. So it does not change the equation. We are just scaling it. And now let's rewrite the second equation because we did not change it. And now that we have opposite variable terms, right, let's add the two equations. So that cancels out. Now we have -20 plus 3, which is going to give us negative 17y. And then we add 84 and 18, and we get 102. If we divide by negative 17, we get y equals negative 6. Now, again, it does not matter which equation we plug it back into. We just need to pick one and plug it in. I'm going to choose the original top equation. So we have x plus 5 times our y value, which is negative 6, x minus 30 equals negative 21 plus 30 plus 30, and we get x equals 9. So our solution is 9 comma negative 6. All right, let's take a look at the second example. So we need to decide which set of variables we want to eliminate. Again, it's going to be difficult to turn a 3 into a 5 with multiplication. We can do it, but we're multiplying with fractions or decimals, and that just doesn't make it nice for us. So let's look at the y values. Remember, there's an invisible 1 here. Turning a 1 into a 2, but we want to create the opposite. So we want to turn into a negative 2 is a lot easier. We can multiply that positive 1 by a negative 2. So the top equation I'm going to write right now stays the same. We're not going to change that, but we are going to manipulate the bottom equation by multiplying everything by a negative 2. So that gives us negative 6x, negative 2y, there's our opposites, equals negative 12. And now we add the two equations. 5 plus negative 6 is negative 1x. Our opposite y values cancel out. And then we have 12 plus negative 12 is 0. Divide by negative 1, and it stays 0. So x is 0. Now we're going to plug that back into either of the original equations. I'm going to plug it into the second one. So now we have 3 times the x value, which is 0, plus 1y equals 6. Cancels out. Y equals 6. So our answer is 0, 6. Okay. Go ahead, try the third example, and then come back and see how you did. See you in a few. All right, welcome back. Let's go ahead and check out the answer to this one. So the answer is negative 3, negative 1. So if you got that, awesome, you did it correct. You can move on to the next section. If not, let's take a little listen here. So the y values, 3 and negative 10, those are not nice numbers for us to scale and then multiply by. 3 does not go into 10 nicely. So we should not choose the y's, but we should choose the x values, but because we can turn a 2 into a 10. Now, the nice part about this one is we just need to turn the 2 into a positive 10 because the top value is already a negative 10. So multiply by 5. That eliminates our x values. And then when we go through solving, you can follow my math there, pause it and take a look. But in the end, you get negative 3 comma negative 1. Awesome. Let's go ahead and check out the last part of the notes, which is substitution by special cases. So when the variables cancel out, notice it says variables, plural. And we get a false statement, such as 2 equals negative 6, right? That's not true. Then same thing we've been talking about. If it's false, it's no solutions. And if both variables cancel out, we get a true statement, such as 5 equals 5, then the system has many solutions. We'll do the first one together, and the second one we'll have you guys try on your own. So this one's nice because we take a look right away, and we have a set of opposite variables right away, no multiplying to do. But then we also look, and the y's are also opposite. So when we add these, right, these are going to cancel out, and these are going to cancel out, which leaves us with 0 equals 8. That is false. Not true, so we're at no solution. All right, take a few seconds and try out number 2. See you in a few. All right, welcome back. Let's take a look at the second example, which includes special cases. This one is not as nice as the first one because we do have to multiply the second equation by -2. And if you notice, it doesn't matter which variable we choose in this case because when you multiply by -2, um, we're going to eliminate both variables, right? -2 turns this into a -2x, turns this into a positive 4y. So when you get down here, you see they both cancel out. And then you also notice that turns the 8 into a -16. So these also cancel out. You're left with 0 equals 0, which is always true. So it's infinitely many solutions. All right, everyone. Fantastic job. Um, we have one more day of notes tomorrow, and then that's our last day of notes for the year. You guys have done great. Please make sure you reach out to your teacher if you have any questions. Other than that, peace out. Have a great rest of your day.